Hello, everyone. I'm very glad to join this meeting as a presenter. So today I have a topic of ACRN boot process and secure boot. This is today's agenda. So the first I will introduce what is bootloader and multi-boot protocol, which used for ACRN boot. The next, I will introduce ACRN hypervisor and its VM boot. And next, I will introduce the ACRN boot components. The last topic is secure boot. Okay, let's go to the first part, bootloader and multi-boot protocol. So what is bootloader? A bootloader is a software that is responsible for booting a computer. So every OS should have a bootloader to load the OS image to the memory and start to run. So ACRN uses the Multiboot and Multiboot 2 protocol to boot the hypervisor. Below is bootloaders that supported by ACRN currently. The first is GRUB, which is a very common for boot Linux. Another one is Intel Slim bootloader. And we also have a self-designed UEFI style bootloader for reference that you can boot the hypervisor, boot ACRN hypervisor without GRUB or SBR. Okay, this is a link for a multi-boot protocol. The multi-boot protocol has two versions. One is multi-boot, another is multi-boot 2. I will introduce it one by one. Multi-boot version 0.6.96. It's a very earlier version of multi-boot. It supports x86 architecture only, and because it's a very early version, so there's no UEFI support. And also, it has no kernel and module relocation support.
So Victor,
yes,
is multi-boot, does that mean it's considered by the community as kind of unstable or like kind of a beta quality? And I guess the other question is, did it ever reach a version 1. something?
No, for multi-boot, I call it multi-boot version 1. Actually, it's a version 0.6.96. It's an earlier version.
Okay.
Also, for next multi-boot 2, it also has only one version.
Okay.
We call it multi-boot 2.
Okay. Okay.
Yeah.
Thanks.
So, yeah. So from an OS image side, it should include a header in its image that indicates it support multi-boot protocol. So there's a magic value in its header, and the header must be contained completely with the first 8K bytes of the OS image, and must be 32-bit aligned. So from this image, so machine we can the bootloader can know that the image support multi-boot or not. So when boot, so from machine side, there's a machine state that some register must tell the payload that which protocol is multiboot 1 or multiboot 2. So there's a EAX register must contain the magic value, and EBX will include the 32-bit physical address of the multiboot infrastructure. So this is multiboot 1. So for multiboot 2, have some improvements. It will support more architectures like x86 and MIX, and also other architecture if you want to enable that is them. It has UEFI support and support kernel relocation, but it's just for kernel relocation. It cannot support the modules relocation till now. So it has a magic value that the multiboot 2 magic in its header, and the header must be contained within the first 32K bytes of the OS image, and must be 64-bit aligned. So it's possible that the image can have both heads, which means it could support both multiboot 1 or multiboot 2. The machine state is there's the magic, the multiboot 2 magic will be in EAX register. And the 32 bits of physical address and multiboot information will be included in EBX. This is an example for x86. For other architecture, it will be in the specific register of their architecture. So any question on this? Okay. So these slides were this slide shows that the multiboot support status in the generic bootloaders. So for SBR, currently it only supports multiboot protocol. It cannot support multiboot 2 protocol. And for GRUB 2.06, it will support both multiboot 2 and multiboot protocol. If you want to boot a payload with multiboot protocol, you can use multiboot and a module, this command pair. If you want to load a payload with multiboot 2 protocol, you can use multiboot 2 and module 2 command pair. So because multiboot does not support UEFI, so if you want to boot the payload with multiboot 2 command, there might be a boot failure because the multiboot 2, because the ACPI RSDP will exist on anywhere. So if you use multiboot command, you will fail to find the ACPI RSDP, which is critical for enable ACRN. Okay, any question? Okay, let's go to the next part. Hypervisor and icon hypervisor and VM's boot sequence. This is a diagram for boot sequence of a hypervisor and a pre-launched VM. So firmware will start to load bootloader, and the bootloader will generate the native multiboot info and load the icon hypervisor to the memory space and start to run hypervisor. So when icon boot, it will pass the native multiboot info and save this multiboot info to its own boot info structure. And with this boot info, because there's the memory map information is stored in multiboot. So we can initialize the EAD20 table based on the multiboot info structure. And we can do init seed and then put the VM and start to run their software VM loader. The software VM loader will pass the module information in MBI structure. That means where the SOS kernel is and where the RAM disk for this kernel and where the other VMs kernel, other pre-launch VM kernel. Then the software VM loader will load these modules to the guest memory space and start to run the VMs. Okay, this is just for pre-launch VM. For post-launch VM, it's launched by a script in SOS VM. That's why we called it post-launch VM, because it's launched after SOS kernel boot. So when SOS VM boots successfully, the device module will launch the post-launch VM kernel to the memory, guest memory, and there's a virtual firmware via OVMF where do the initialization, and OVM will load the guest kernel and start to run. Okay, any question? Okay. Okay, next is introduction of boot components. So
Victor,
hypervisor binder, yes.
Hi, Victor. I think there is
Yes.
one question from Vinay in the chat window. He's asking in the pre-launch VM, in the boot sequence, when and how the pass-through of the device happen.
I'm sorry, what's the question?
Hi,
Can you say it
Victor, Vinay here
Yes.
again. Yeah, hi. So in the pre-launch, the pass-through of the devices, at what stage it happens, when and how it happens? So you explained how the VM get launched, and what about the pass-through of the devices, where that information will be passed to the pre-launch VM?
Yes.
Yeah, hi Vinay. So actually, we have create a VM function for each VM. For pre-launch VM, we will also call this function. In this function, we will do the initialization of the pass-through device. So for every pre-launch VM, we should first do the create a VM and the launch VM for this pre-launch VM. Then we go to the service VM. So it's done by doing create a VM. So
Okay.
I don't know. Yeah, is it to answer your question or?
Yeah. Okay. I think I got the information. Yeah. Thank you.
Welcome.
Okay, back to the slides. Below the icon components, so hypervisor binary, it will act as a multi-boot kernel. It will be loaded first by the hypervisor, by the bootloader, and then the guest kernel image and the guest ACPI binary, or if RAM disk image for the kernel for this VM, it will act as multiple modules. You can use modules command to load these modules. So bootloader like GRUB will load the these components to the guest to the host space, host memory space. This is an example for a GRUB configure. Sorry. Yeah, if you want to put icon with multiboot protocol, you can use multiboot command to load hypervisor binary, and use module command to load the components, the guest kernel, RAM disk, or ACPI. So there's a quick for multiboot command parameter. It calls quick modules after kernel. With this parameter, the modules will be loaded after the hypervisor. But unfortunately, there's no such quick for multiboot in Multiboot 2. So with Multiboot 2 protocol, GRUB might put the modules anywhere outside space of hypervisor. So after the from the module command line, you will find there's a we call tag after the file name. The tag is used to identify which image is used for which VM. So for example, so here Linux be the image means the file, the file that modules load is for SOS kernel. The tag of Zephyr raw image means the file that GRUB loaded is Zephyr kernel. So you can configure this tag in your configuration XML files. Okay, any question on this? Okay, here's the last part, secure boot. This is a verified boot sequence with SPL bootloader. So the CSE which means converged security engine. The hardware engine will verify SPL bootloader. And SPL will verify the guest kernel, the safety OS kernel, and the service OS kernel. And in service VM, it will verify device module and OVMF through DM Verity. So OVMF will start the guest side verification process. So this is a trust chain with SPL bootloader. So if the bootloader is GRUB, the CSE will verify a UEFI firmware, and UEFI firmware will verify shim and GRUB. A GRUB will verify icon and the service VM kernel and pre-launch the VM kernel. Then same as the process in SPL, that service VM kernel verify device module and OVMF through DM Verity. Sorry, I'm sorry. Here's a mistake here. It's not icon DM. It should be VM DM Verity. So user VM OVMF will start the guest side verified process. Let me do a change here. Okay, so if customers has concern on GRUBs, or if customer don't want to use GRUB as a bootloader, so here's another solution that we can use UEFI stub to replace GRUB. In this case, CSE hardware verifies UEFI firmware, and UEFI verifies shim, and shim verifies the packaged icon.EFI, which is a EFI application. So icon.EFI will run EFI stub code and unpack all icon components. So service VM will verify device module and OVMF through DM Verity. And last, that user OVMF starts the guest side verified boot process. So this is a trust chain in without GRUB on UEFI platform. Okay, any question on this? So if no questions, here I'll finish my presentation.
Yeah. Here I just want to add some, story here. So why customer or users do not want to use GRUB? This is because we are using GRUB Multiboot command line to do the boot, but there is a CVE regarding to the Multiboot command in the GRUB. And the other thing is that we want to use the GRUB GPG verification method, which is not the one case of UEFI verification flow. So actually, the trust chain may not be break, but during the boot of the ACRN, we may just break the UEFI verification method, which means that before ACRN boot, we can use UEFI verification, but after ACRN boot, we just use GPG, use the GRUB Multiboot GPG method to verify the ACRN hypervisor binary. So it may not be accepted by some customers. They want to use one unique, UEFI key to do the secure boot. So this is the new changes for us is we will just add back the EFI stub and to package all the components, ACRN hypervisor, and also including service images, and also the other pre-launch VM image, and also include some HPI binary into one package. And we will do the EFI verification together with one image, with one image as ACRN.EFI based on EFI verification process. So it based on this solution, we can meet customers or some users requirement. We will keep use the UEFI verification methods, and there is no CVE program of the GRUB Multiboot command. Yeah, just some additional note.
Okay, thank you.
Thank you, Victor. Thank you, Jason. Thank you all.